Hello student, here is the question that the hollow, thin, cylindrical, current carrying state pipeline which statement is correct? Okay, so hollow cylindrical current carrying state pipe is there. So here is the current carrying state pipe is there. That's a hollow. Okay, because there is no current inside. Whatever the current is on the surface. Okay, so you can see that's you can see now. Here is the infinite. Now, so here you can see magnetic field inside the pipe is not zero. So you can see inside, if I am considering Ampere's loop like this, if I am seeing the front top view of this, so it will be like that. That's the current is like this. Okay, so top view will be like that. That's the top view. So if I am considering Ampere loop inside that one, so there is no current inside. So I will write that's a B vector dot dl vector. So that will be equal to mu naught into, there is inside that Ampere loop there is no current there. All the current is on the surface. So that will be equal to 0. So I will write that's B equal to 0. So magnetic field inside the loop will be equal to 0. So inside the pipe will be equal to 0. But it's mentioned it's non-zero. So it cannot be your answer. Magnetic field outside the pipe is 0. Outside the pipe you can see, if I am considering that loop, okay, so here I can write that's integration B vector dot B out. Okay, so here is the B vector dot dl vector mu naught into, for this loop I am writing. So you can see in this loop, this Ampere loop, all the current which is on the thin cylinder, that total current will be inside the loop. So you just write that equal to I. Okay, so here is the loop length will be equal to 2 pi r. So B into 2 pi r is equal to mu into I. So magnetic field will be equal to, B is equal to mu naught into I upon 2 pi r. It is just like infinite current carrying infinite long wire, magnetic field due to infinite long wire. So it will be like that. Okay, so it's not 0. Okay, so it's not 0. But here it's saying that magnetic field outside the pipe is 0. No, it's not 0. Electric field outside the pipe is 0. So outside the pipe you can see, if you are considering to calculate the magnetic field, you have to consider the Gaussian surface. So here there is a loop. This is the loop. This is the current carrying hollow cylindrical surface wire, cylindrical straight pipe. Okay, so here if you are considering a loop outside that, so you can see in this wire number of protons, electrons are same. Okay, so total net charge inside the loop, inside the Gaussian surface, that's equal to integration B vector dot dA vector. Okay, so that will be equal to net charge enclosed by that will be equal to Q enclosed. Okay, so whatever the number of electron which you have, same amount of proton will be there. Okay, so it will be equal to Q minus Q and upon epsilon naught, and that's coming out to be 0. So you can write that integration B vector dot E vector dot dA vector is equal to 0. So E vector dot dA vector, it will be equal to 0. So electric field will be equal to 0. So for outside electric outside the pipe, electric field will be 0. So that option is correct. So option number 3 is the correct answer of this question. Electric field on the surface is not defined. Okay, so you can calculate that. Okay, so here is the third option will be the correct answer of this question. Thank you.